All right, so this video is pertaining to the Doppler effect. So again, what you have written down in your notes for the Doppler effect again is the change in pitch, all right, due to the change in position of the sound of the object making the sound. So usually you hear this in the case of sirens. Like again, we talked about police sirens or firefighter or fire truck sirens or ambulance sirens. Again, when they're getting closer to you, they have a different sound as opposed to when they pass by you. All right, you may notice that the sound changes, and usually what's changing is the pitch. All right, and so this video is going to kind of help us understand why that is the case. All right, for the Doppler effect of how pitch changes because an object making a sound changes its position. Now I will pause the video during parts here to explain what you're looking at.
The Doppler effect. In Sheldon's words,
it's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
The Doppler effect is perhaps best explained visually. So here's a thing that is emitting waves. It could be a fire truck emitting sound, it could be a star emitting light, it could be a duck creating ripples on a pond.
All right, so again, right here, this is the object making the sound. All right, so that's the key here. Just like yesterday in the video we watched with the interference, remember the guy was making waves in the pond, right? These are those waves. So in this case, these are representing the sound waves. All right, and so if these are the sound waves, then these are the distances between the waves. So what is that called? Wavelength. Okay. So if I have a wavelength, once I have a wavelength, then I can use the wavelength to figure out what, Jessica? Wait, never mind. He saves you. Good job, Coco. Frequency. All right. I know he just beat you this time. So if I have a wavelength, I have a frequency. So again, bottom line is this. Anywhere there's a wavelength, there's a frequency. But if this is a sound wave and a sound wavelength, where I have a frequency, I have a pitch, the highness or lowness of sound. Okay? So what we're saying here is this. If you look, the space between every wave on every side of this is all the same. So no matter what, because the object is not moving, everywhere around the object, you hear the same sound, the same pitch. Does that make sense? Oh, God, you guys are like my first period now. Now you get dumb. Hey, no, nobody's saying anything. Okay? I don't ever start to repeat it. You watch the video. All right? The whole area is, again, these are sound waves. All right? The gap between the waves is the wavelength. Because these are wavelengths, you can get frequencies. Because this is a frequency of a sound, this can determine pitch. So therefore, if I'm standing over here to the duck, I hear the same pitch as if I were standing on this side of the duck. Because the wavelengths are the same everywhere around it. So the pitch is the same everywhere around it. Got it? And you're still quiet. All right.
Yeah, I got it.
Okay.
Pond. Those are all waves, and they all look something like this. We see the Doppler effect happening when the thing that is emitting waves moves. In the direction it's moving, the wave...
So now, the object that's making the sound, now it's moving. Okay? At the same time, it could be you moving. Because the whole point here is, as the sound producer and the sound observer get closer, what happens is these gaps get narrower. All right? Jessica, here's where you can redeem yourself. So if these gaps, which we called wavelengths, if these wavelengths now have gotten smaller, then what has happened to the frequency? Coco, say it out so she can hear. It increased. All right? Imagine. No disrespect, Coco. I'm giving you credit. All right?
Don't do that.
All right? But the whole issue here is this. We just had a front row have to tell a back row.
All right. Good.
The point now is this, Mr. Malcolm. If this right here has a higher frequency, then over here, would I hear a higher pitch or a lower pitch?
Say it again.
If here's a higher frequency, would I have over here then a higher pitch or a lower pitch? Higher pitch. So now here's where I know you really get it. So would this be sounding like Josephine or would it be sounding like me?
Josephine.
Correct. All right. So over here, I'm going to hear the high pitch. All right. Over here, the wavelength has gotten bigger. All right. Because now we notice the wavelengths are not the same. The wavelengths on the left side are smaller, frequency higher. Wavelengths on the right side are bigger. So frequency lower, pitch is lower, sound is more like me. All right? And so that's kind of what we see going on here in relation to the Doppler effect.
Wavefronts bunch up, and behind it they spread out. If our object is moving towards a stationary observer, these bunched up waves are observed at a high frequency, and if the object is moving away from a stationary observer, the waves are observed at a lower frequency. So that is the Doppler effect, the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer. It makes sense, but it gets interesting when you consider some of its applications. So let's say you are standing in the middle of a road. That's you, and a car drives past you very fast. As it does so, it honks its horn because you're standing in the middle of the road. The horn to you might sound something like this.
So notice, listen to this, the change that the horn sound makes. Because obviously, if you're in a car and you're pressing on the horn, does the horn pitch change? No, it just makes the same constant sound, right? But if you're being honked at by a car as it's driving past you, the horn sound does sound different as compared to getting closer as opposed to getting away. And it sounds a little bit like this right here.
So it starts at a high pitch and moves to a lower pitch, even though from the driver's perspective, the horn is playing the same pitch the entire time. So what's going on? As the vehicle's coming towards you, the sound waves that it's emitting bunch up, and so are delivered to you at a high.
So if we notice in the front, which is where you are right now, wavelengths small, frequency high, pitch high, sound like Josephine, right? But behind the car, wavelength big, right? Frequency low, sound or pitch low, sounds more like me. So as the car is getting to you, you're going to hear the high sound, but then once it gets past you, here I can kind of mute. Now, once the car kind of gets past you, then you can see that the frequency now is going to drop because now you're getting those big wavelengths as it's going away from you. All right, and that's what basically is the Doppler effect, the change in the sound of the change in sound because the object making the sound is moving. If it's moving to you, frequency high, pitch high. Moving away from you, frequency low, pitch low. All right? Anybody have any questions about the Doppler effect? So we're good? Because that's going to be a big idea. Now, do me a favor. Look at your reference sheet real fast. I need you to take out your reference sheet. That's the sheet that's got the periodic table. If you don't have it, don't let me know because today I don't really care. But I'm looking at the side. The side you're going to look at is the side that is not the periodic table. Here's the important part about Monday's lesson. Okay, Monday's lesson. See the diagram that is on the upper right side? You'll see words that say things like microwaves, radio waves, ultraviolet, right? Well, here's the thing. Right now, you may not have any idea what you're looking at in that diagram. My goal on Monday is to make sure you know how to look at it, how to read it, how to get information from it, and then how to answer questions where you have to use it to get the answers. That's a skill, and it only happens one day. So if you are not here on Monday, then obviously you're going to have difficulties when you have to use that diagram, all right, for any kind of questions that pertain to that. All right, so there's going to be quite a few questions that use that diagram because they're easy questions as long as you know what you're looking at. All right, does anybody have any more questions for today? All right, then. This concludes the recording of this video.